Welcome to today's presentation. Welcome to this session on electrical safety, specifically focusing on our Rajgully unit in Maharashtra. This slide highlights the importance of electrical safety training, which is a crucial part of our overall safety program. Ensuring everyone understands the hazards associated with electricity and follows proper safety procedures helps prevent accidents and injuries. Electrical safety isn't just about avoiding shocks or burns. It's about creating a safe working environment for all of us. Proper training equips our team with the knowledge to identify potential risks, use electrical equipment safely, and respond effectively if something goes wrong. Remember, safety is a shared responsibility. By adhering to these safety practices and staying vigilant, we protect ourselves, our colleagues, and our workplace. This training is a key step in fostering a culture of safety across the entire Olam global agri operation. Let's take a closer look at the contents of electrical safety. In this section, we'll explore the key points that help us understand how to stay safe when working with electricity. First, it's important to recognize that electrical safety isn't just about avoiding shocks. It's about preventing fires, equipment damage, and even life-threatening accidents. We'll discuss the proper use of protective gear, like gloves and insulated tools, which are essential in minimizing risks. Additionally, understanding the significance of regular maintenance and inspections helps catch potential issues before they become dangerous. Remember, safety is a shared responsibility, and being aware of these key points keeps everyone safe and ensures smooth operations. This foundation ties directly into our overall goal of creating a safe working environment for everyone involved. Electrical safety is all about working with or around electricity in a way that helps prevent accidents, injuries, and damage. It's not just about avoiding shocks. It's about following the right procedures and using the correct equipment to keep everyone safe. When we talk about electrical hazards, we're referring to risks like electrical shock, burns, fires, or even explosions. This training is designed to raise awareness, so you can spot potential hazards before they become serious. We'll go over safe work practices and emphasize the importance of complying with safety standards. You'll learn how to identify risks, use protective gear properly, and follow essential procedures like Lockout/Tagout or LOTO, which is crucial for preventing accidental energization of electrical systems. The goal here is to create a safe environment around electrical systems, protecting both people and property. Remember, safety isn't just about following rules. It's about making smart choices every day to prevent accidents. So, keep these key points in mind as we move forward, and think about how they connect to the bigger picture of staying safe at work. This slide doesn't contain enough information. That's why we're moving to the next slide. Let's take a closer look at some of the main hazards associated with electrical systems, starting with overloaded circuits. When circuits are overloaded, they draw too much current, which can cause the wiring to overheat and potentially lead to fires. This is especially common in workplaces where multiple high-power devices are used simultaneously, making it crucial to manage load properly and ensure circuits are not overloaded. Next, wet conditions pose a significant risk. Water is a great conductor of electricity, so when electrical equipment is exposed to moisture, the chances of shocks increase dramatically. That's why it's essential to keep electrical equipment dry and elevated, particularly in environments prone to water exposure, to prevent accidents. Now, improper use of equipment is another critical hazard. Using damaged tools or equipment that isn't certified can lead to unpredictable failures and accidents. Always follow the manufacturer's guidelines when operating electrical tools, and make sure the equipment is in good condition before use. Moving on, the importance of personal protective equipment, or PPE, cannot be overstated. Not wearing gloves, safety glasses, or flame-resistant clothing significantly raises the risk of injury. PPE acts as a vital barrier against electrical shocks and burns, so always ensure you're properly equipped before working on electrical systems. Finally, inadequate training is a major concern. Untrained personnel may not recognize hazards or know the correct safety procedures, which increases the likelihood of accidents. That's why ongoing, regular training is essential for everyone involved in handling electrical systems. Proper knowledge and preparation are key to maintaining a safe work environment. When it comes to safe work practices, the first thing to remember is to always assume wires are live until you've verified otherwise. This means never taking chances. Always test and confirm before proceeding. Keeping your work areas dry and clean is also crucial, as moisture and clutter can lead to electrical faults or accidents. Using insulated tools and wearing the right personal protective equipment, like gloves, eyewear, and flame-resistant clothing, helps protect you from potential hazards. It's equally important to keep a safe distance from energized equipment to avoid accidental contact. Before you start any work, make sure to inspect all equipment and cables for any signs of damage or wear. Always verify that the power is disconnected before touching any electrical components. Never assume it's off. Following proper lockout/tagout procedures is essential to isolate energy sources and prevent unexpected energization. Also, ensure all electrical systems are properly grounded to reduce the risk of electric shock. During the work, avoid wearing metal jewelry or conductive items that could accidentally contact energized parts. Use voltage testers to double-check that systems are de-energized. Never rely solely on assumptions. Keep flammable materials away from your work area, as sparks or electrical faults could ignite them. When dealing with high-voltage systems, it's best to work with a buddy or supervisor who can assist or call for help if needed. Once the work is done, only restore power after confirming everything is completed, and it's safe to do so. Remove tools and debris from the area to avoid hazards. Make sure to report any hazards or incidents immediately to keep everyone safe. Finally, document any changes made to the system and label them clearly, which helps maintain safety and clarity for future work. Following these practices ensures not only your safety, but also the safety of everyone around you. Let's go through some common mistakes to avoid when working with electrical systems and how to stay safe. First, working on live circuits is extremely dangerous because it poses risks of shock, arc flash, or even fatal injuries. The best practice is always to de-energize the circuit and verify it with a tester before starting any work. Next, skipping personal protective equipment, or PPE, significantly increases the chance of burns, electric shock, and eye injuries. Remember, wearing full PPE should be a standard part of every electrical task, no exceptions. Using damaged tools or cables is another critical mistake. Damaged equipment can cause short circuits or shocks, so always inspect your tools and cables thoroughly and replace any that are compromised before use. Overloading outlets or circuits can lead to overheating and potentially cause fires. To prevent this, distribute the electrical loads properly and ensure circuit breakers are functioning correctly. Ignoring lockout/tagout procedures is a serious safety lapse. These procedures are designed to prevent accidental energization during maintenance, so always follow lockout/tagout protocols strictly. Poor housekeeping around panels also creates hazards. Cluttered areas can cause trips or fires, so keep your work area clean and free of unnecessary clutter. Allowing untrained personnel access to electrical equipment increases the risk of accidents. Make sure only qualified and trained staff are authorized to work in these areas. Finally, working in wet conditions greatly raises the risk of shock. Always keep electrical work areas dry, and if necessary, use ground fault circuit interrupters, or GFCIs, to help protect against electrical shock. Overall, following these safe work practices is essential to protect yourself and others, and to ensure a safe working environment. Let's take a moment to talk about the importance of personal protective equipment, or PPEs, in our work environment. PPEs are essential for ensuring our safety when dealing with electrical hazards. For example, insulated gloves are crucial because they help prevent electric shocks, especially when working with live wires. Arc-rated clothing provides protection against arc flashes and burns, which can occur unexpectedly during electrical faults. Wearing a safety helmet is equally important. It shields your head from falling objects and potential arcs that could cause injury. Face shields or goggles are vital for eye protection. They guard against sparks and ultraviolet radiation that can damage your eyes during electrical work. Dielectric footwear helps prevent grounding and electric shocks by insulating your feet from the ground, reducing the risk of electrocution. Lastly, hearing protection is often overlooked, but is essential because it shields your ears from the loud noises of arc blasts, preventing long-term hearing damage. All these PPE items work together to create a safer working environment, aligning with our overall goal of minimizing risks and protecting ourselves on the job. Let's take a closer look at the ARC-rated clothing category. This category is crucial because it helps us understand the protective gear that workers rely on when exposed to electrical arcs. The key point here is that arc-rated clothing is specifically designed to withstand the thermal and radiant energy produced by an arc flash, helping to prevent serious injuries. What's important to remember is that the arc rating, or AR, indicates the level of protection the clothing provides. It's essential to choose the right arc-rated clothing based on the potential incident energy levels in your work environment. This ties into the overall theme of safety and risk mitigation, emphasizing that proper protective clothing is a vital part of an effective safety program. By understanding the categories and ratings, we can make informed decisions to safeguard ourselves and our teams. Let's talk about what LOTO actually is. Lockout/Tagout, or LOTO, is a safety procedure designed to protect workers from the unexpected release of hazardous energy when they are servicing or maintaining equipment. It's all about ensuring safety first. LOTO involves two main actions. First, lockout, which means securing energy-isolating devices using padlocks or specialized lockout tools. This step prevents the equipment from being accidentally turned on while someone is working on it. Second, tagout, which involves attaching clear, durable warning tags to the equipment. These tags serve as a visual reminder that the equipment is under maintenance and must not be operated. Together, these actions create a safe environment by controlling energy sources and communicating clearly to everyone involved. This is a crucial part of our overall safety culture and helps prevent accidents before they happen. Let's talk about the importance of lockout/tagout in electrical safety. First, it prevents the unexpected release of hazardous energy, such as residual capacitor charges or live circuits, which can be extremely dangerous. This process effectively eliminates risks like electrocution, arc flashes, and severe burns, helping keep everyone safe. Addressing this safety step also tackles one of OSHA's top citations: failure to control hazardous energy. By doing so, we significantly reduce the number of serious workplace accidents caused by insufficient isolation. Another key benefit is that it builds confidence among the workforce. When employees know that proper procedures are in place to prevent near misses and minor shocks, they feel more secure and engaged. Lockout/tagout also helps minimize equipment damage and unplanned downtime, which in turn lowers repair and replacement costs. Plus, by promoting safer maintenance practices, it extends the lifespan of our assets. Most importantly, fostering a culture of accountability means every employee recognizes hazards and takes responsibility for controlling them. When we all commit to these safety practices, we create a safer, more reliable work environment. Let's start with notifying all affected employees. This includes coworkers and other departments who might be impacted by the shutdown. Clear communication is essential so everyone knows what's happening and can take necessary precautions. Next, prepare a LOTO permit and make an entry in the LOTO register. This step helps keep a formal record of the lockout process and ensures accountability. Then, review the specific procedure for the equipment you're working on. This is critical because it allows you to identify all energy sources involved and understand the proper shutdown sequence. Knowing exactly how the equipment operates helps prevent accidents. After that, shut down the equipment using the normal stopping procedures. Follow the established steps to turn off the machinery safely. Once the equipment is off, isolate all energy sources. This means disconnecting circuit breakers or switches that supply power to the equipment. It's important to do this thoroughly to prevent any accidental energization. Securely attach individual locks and tags to each energy isolation point. Make sure the tags include your name, department, and the reason for the lockout. This way, everyone knows who is responsible and why the equipment is locked out. After isolating the main power, it's crucial to release any residual energy. For example, capacitors may still hold a charge, so take steps to discharge them safely. Next, verify isolation by performing a tryout. Confirm that the equipment is completely de-energized and won't start unexpectedly. Test residual energy sources to ensure safety before proceeding with work. Now, after servicing is complete, only the person who applied the lock and tag should remove the LOTO devices. This prevents accidental re-energization. Reinstall guards and other safety devices, ensuring the work area is clear of tools or debris. Then, restore power to the equipment carefully. Finally, inform everyone that the work is finished and the equipment is ready for use. Clear communication at this stage ensures a safe and smooth return to normal operations. Let's take a closer look at the LOTO station and the various devices used in lockout/tagout procedures. The LOTO station is a central, secure storage area where we keep all our lockout and tagout devices. This helps ensure that all energy sources are properly isolated before maintenance or service work begins. Starting with push-button lockouts, these are designed to cover control buttons to prevent accidental activation, which is crucial for safety. Group lockout boxes are useful when multiple workers need to lock out a single energy source. They hold all the keys so everyone can work safely together. Cable lockouts are flexible and versatile. They use a cable to lock multiple or irregular energy points, making them ideal for complex setups. Valve lockouts are used to secure gates, ball, or butterfly valves, effectively stopping fluid or gas flow when needed. Electrical lockouts include devices like circuit breaker lockouts, plug lockouts, and switch lockouts. These are essential for isolating electrical energy safely. Tagout tags are simple but vital. They communicate the lockout status, the reason for it, and who is responsible, ensuring clear communication. Lockout hasps are devices that allow multiple locks to be applied to a single energy source, enabling multiple workers to lock out the same point simultaneously. Padlocks are perhaps the most common. They're basic lockout devices with unique keys, used to secure energy isolation points. Each of these devices plays a critical role in our overall safety strategy. By using the right lockout devices at the right time, we ensure that energy sources remain safely isolated, preventing accidents and protecting everyone involved. Let's take a closer look at the main hazards in electrical work. First up is electrical shock, which can occur in two ways. Direct shock happens when you come into contact with live electrical parts like wires or terminals. Indirect shock, on the other hand, occurs when you touch conductive surfaces that have become energized due to faults in the system. Next, we have electrical arcing. This is a sudden discharge of electricity between conductors, and it can be extremely dangerous. Arcing can cause severe burns, damage equipment, and even start fires, so it's a serious hazard to be aware of. Burns are another major concern. These can result from arc flashes, hot surfaces, or electrical fires. Burns caused by electricity can be thermal, electrical, or chemical, depending on the situation, so they're often very severe. Moving on to explosions and fires. These can happen if there are short circuits, overloads, or sparks near flammable materials. The consequences are not just physical injuries, but also significant property damage, which underscores the importance of proper electrical safety. Lastly, faulty wiring is a common issue. Poor connections or damaged insulation can lead to overheating and fires, and they significantly increase the risk of electric shock and equipment failure. Understanding these hazards helps us appreciate the importance of proper safety procedures and vigilant maintenance in electrical work. Hazardous conditions in electrical work are a serious concern that we need to be constantly aware of. These conditions can arise from a variety of factors, such as faulty wiring, damaged equipment, or improper grounding. When these hazards are present, the risk of electric shock, burns, or even fires significantly increases. It's crucial to identify and address these conditions promptly to prevent accidents and injuries. Throughout this presentation, we've emphasized the importance of safety protocols, and understanding these hazardous conditions is a key part of that. Recognizing potential dangers before they cause harm helps us maintain a safer work environment for everyone involved. So, always stay alert to these hazards and follow proper safety procedures to protect yourself and your colleagues. Let's now turn our attention to safety devices for electrical safety. These devices are crucial in protecting us from electrical hazards and ensuring a safe working environment. First, we have circuit breakers, which are designed to automatically cut off power when they detect an overload or short circuit. This prevents damage to equipment and reduces the risk of fire or electric shock. Next are fuses, which serve a similar purpose by breaking the circuit when excessive current flows through them. They act as a sacrificial device, meaning they need to be replaced after they protect the circuit. Ground fault circuit interrupters, or GFCIs, are especially important in areas where water is present, like kitchens or bathrooms. They quickly shut off power if they detect a ground fault, protecting people from electric shocks. Residual current devices, or RCDs, work similarly by disconnecting the supply when they sense leakage currents. These are vital in preventing electrocution, especially in outdoor or damp environments. By understanding and properly using these safety devices, we can significantly reduce electrical hazards and protect ourselves and others. Remember, safety devices are our first line of defense in any electrical setup, and their correct application is essential for maintaining a safe workspace. Let's talk about safety guidelines, specifically regarding the electrical panel safety. When working around electrical panels, it's crucial to prioritize safety at all times. Always remember to follow proper procedures to prevent accidents. For example, before doing any work, ensure the power is turned off and properly locked out to avoid any unexpected energization. Wearing the right personal protective equipment, like insulated gloves and safety glasses, is essential to protect yourself from electrical shocks or sparks. Also, never bypass safety devices or take shortcuts. These can be very dangerous. Staying alert and cautious helps us maintain a safe environment for ourselves and others. By adhering to these guidelines, we reinforce our overall safety culture and make sure everyone goes home safe at the end of the day. Safety around electrical panels isn't just a rule, it's a vital part of our responsibility. Let's talk about electrical panel safety, which is a crucial part of our overall electrical safety strategy. First, one of the biggest hazards is electric shock. This can happen if someone accidentally touches live parts or if there's faulty wiring. To prevent this, it's important to use insulated tools, always wear the proper personal protective equipment, and ensure that panels are kept closed and locked when not being worked on. Next, we have arc flashes. These are sudden releases of energy that can cause severe burns and damage equipment. To avoid this, maintain a safe distance, wear arc-rated PPE, and always follow the correct procedures when working near these panels. Another significant risk is fire and explosion, which can result from short circuits, overloads, or working in environments with flammable materials. The key prevention measures include avoiding overloading circuits, keeping flammable substances away, and performing regular inspections to catch issues early. Water exposure is also a concern because water increases the risk of shock and can cause equipment to fail. To mitigate this, keep panels dry, install them in elevated or protected locations, and use ground fault circuit interrupters, or GFCIs, in areas prone to moisture. Improper access is another safety challenge. When untrained personnel tamper with panels, accidents happen. We can prevent this by locking panels, posting clear warning signs, and restricting access to authorized personnel only. Poor maintenance can lead to loose wires, dust buildup, or corrosion, all of which increase the likelihood of faults. Regular inspections, cleaning, tightening connections, and replacing damaged parts are essential steps to keep everything in safe working order. Overloaded circuits are a common cause of overheating and fires. Proper load distribution, using circuit breakers, and monitoring current usage help prevent overloading and keep our systems safe. Finally, unlabeled circuits can cause confusion during operation or emergencies, potentially leading to dangerous mistakes. The best practice is to clearly label all circuits and update those labels whenever modifications are made. All these points tie back to our overall goal, ensuring that our electrical panels are safe, reliable, and well-maintained to protect everyone working around them. Let's now turn our attention to electrical transformer safety. This is a crucial aspect of our overall safety protocols. When working with electrical transformers, it's essential to follow strict safety guidelines to prevent accidents and injuries. Always remember, transformers handle high voltage, so proper training and caution are a must. Make sure to wear the appropriate personal protective equipment, such as gloves and safety glasses. Before starting any work, ensure the transformer is properly grounded and that all power sources are disconnected. Regular inspections are also vital. Look for signs of damage, corrosion, or leaks that could indicate a problem. Never attempt repairs unless you're qualified and authorized to do so. And of course, always adhere to the manufacturer's instructions and safety standards. By staying vigilant and following these guidelines, we can significantly reduce risks and ensure a safe working environment for everyone involved. Now, let's take a closer look at some of the key hazards associated with electrical transformers and how we can prevent accidents. First, electric shock is a serious risk that can happen if someone comes into contact with live parts or faulty insulation. To prevent this, it's crucial to always use the proper personal protective equipment, ensure all insulation is intact, and restrict access to trained personnel only. Next, there's the danger of fire or explosions, which can occur due to overheating, oil leaks, or short circuits. To mitigate these risks, regular maintenance of cooling systems is essential, along with routine inspections and keeping the area free of flammable materials. Oil leaks are another concern, especially since transformer oil can cause both fires and environmental damage. Preventative measures include inspecting seals and tanks regularly and using containment trays to catch any leaks. Overheating is a common issue, often caused by overloads or insufficient ventilation. Monitoring load levels, ensuring proper airflow, and installing temperature sensors can help us catch problems early before they escalate. Arc flash is a sudden release of energy during faults or switching operations, and it can be extremely dangerous. Wearing arc-rated PPE, maintaining a safe distance, and following proper switching procedures are vital for safety. Finally, unauthorized access poses a risk because untrained personnel might inadvertently cause accidents. To prevent this, enclosures should be locked, warning signs posted clearly, and access limited strictly to qualified staff. All these points tie back to our overall goal: safety first. By understanding these hazards and implementing the right prevention measures, we can protect ourselves, our colleagues, and the environment from potential electrical accidents. Thank you so much for your time and attention today. I truly appreciate your engagement and interest. Remember, the key points we've discussed are all about understanding the importance of this topic and how it can impact our work and our goals. I hope you found the information helpful and inspiring. If you have any questions or want to explore further, please don't hesitate to reach out. Thanks again for being such a great audience. I look forward to seeing how you apply these insights moving forward.